The title of the talk is Limited WIP for Developers, where WIP is an acronym which stands for Work in Progress. So there are, I guess, different ways to think about work in progress. And I'll just then go on with the history of where I learned about it. So I guess that's a standard board many teams would have maybe in their office and now virtually. And as you can see, there are a few columns where on the left is backlog, usually with lots of items. Then you would have some design column if you're doing a website and there are people who create design. Then you would have development team doing something, let's say full stack, and then you would have QA, and then it moves to done. So that's like a standard board, but if you are doing Kanban, then there is a concept of limited work progress, so you can add constraints on your column. So here there are now 3 numbers at the top. They mean the maximum amount of cards that can be in that column. So far in design, we have 1 card, the maximum is 3, so it's fine. In development, we have 5 cards, but there are just 3 now. So that's also fine. And in testing, we're kind of full on. It's like 3 is maximum and we have 3 cards in there. So the idea is that if I'm a developer and I developed a feature, then I'm finishing my card and I'm kind of moving it to the next column. However, because there is a limit 3, I cannot do it. So that's illegal. And I have to put it back. And what I can do, I cannot really finish my task. So maybe I should go and like talk to QA and figure out what I can do to help them and so on. So that's the overall idea of limited work in progress. That's where I heard it from the first time, and it's like I think the one of the main ideas in Kanban. So if somebody's doing Kanban, like they say they're doing Kanban, but they don't have work in progress limits, they're not really doing Kanban. So that's one thing. And then it's a bit also counterintuitive. Why would you limit work in progress? But it's counterintuitive because our intuition is that we should utilize all possible resources to the maximum at all stages. So in this case, like development team, if I finished, I just move on the card. But if you think in an end-to-end point of view, like the whole company point of view, then and you start measuring the throughput of the whole company, it's a bit counterintuitive that actually overall throughput will improve if you don't utilize all resources that you have or all people working all the time. And this is a bit like a strange thing, but there is the whole theory of constraint kind of field where they study it, I suppose. I read this book a few years ago. Maybe I should read it again, but I'm recommended it because I read it. It was quite interesting. It's an interesting genre of business novel because it's teaching you, like the main character is a manager at an actual factory, and it describes his life, but like he's having like problems at work and they're trying to solve them, and it illustrates how not utilizing all resources can help overall throughput and like similar ideas by telling you a story of the life of that person. So that's a book I would recommend. Or just in general, you can search for theory of constraint. So that's the idea from limited work in progress, from Kanban and so on. And it was used for actual production, for like production of physical things. And then there is an idea of taking it and applying it at a lower level on coding level. So I wrote this plugin for IntelliJ IDEs, which is called limited work in progress. And it has like few tools in there, which like help you stick to like certain workflows. And it has like 3 components, which we will see. The top, you can see the component which watches the size of your changes and kind of nags you, telling you made too many changes. The second component will automatically undo all your changes every 5 minutes. And the third component is TCR, test and commit and revert, and I'll explain it like later. So like most of this session will be just me like writing code, and then I guess we can like talk, or I can rant myself. And to do live coding, I'll use IntelliJ and Kotlin. And I'll use this simple problem of fizz-buzz-woof. I deliberately choose a very simple problem so that we're not distracted by the problem itself. For example, I could have done like regex, but then I think regex matching itself is a bit confusing sometimes. So fizz-buzz-woof deliberately super simple. So if you haven't heard about it, it's the problem of converting a number into a string. And if the number is divisible by 3, you say fizz, 5, buzz, woof, 7 woof, and all the combinations of those. So like 15 will be fizzbuzz, but if it's not divisible by any of these, this is just a number. For example, 8 will be 8. So that's the whole problem. And using everything that I mentioned in the intro, here is the agenda. So I'll do like a couple demos. One will be test-driven development with auto-revert. Then it will be TCR, and then it's like takeaways and conclusions. If anyone has questions now or any comments, please feel free. So moving on then to part 1, which is TDD with auto-revert and change size limit, as I mentioned. So I'll just move on to coding then. Here I have IntelliJ IDE. It's also early access program. So if it crashes, that's going to teach me a lesson. And it's a Kotlin project. To be clear, it's a Kotlin JVM. So if you don't know Kotlin, Kotlin can be compiled to normal JVM like Scala, for example, or you can write Kotlin native or Kotlin JavaScript. This is just normal Kotlin, I would say. And I have this plugin enabled. So if I go to settings, in the settings, I have limited whip and progress, and then I have enabled this auto-revert enabled and watchdog enabled at the top. So that's why we can see these 2 pop-ups. And because we are doing test-driven development, let's just write a failing test, I suppose. We can write, say, 1 should equal 2. Right, and let's run that. So this fails as expected. We expected 2, but it was 1, so I can try and fix it now and run the test and see that it fails. So at the bottom of the screen, you can see this pop-up green, it says test passed. You can see also that there is like 2 pop-up windows here. One is auto-revert. It's been counting down from 1 minute to 0. When it reaches 0, it will be all reverted. And there is another one, change size, which says 2. That's the 2 lines you can see on the left side, the blue and green. So that's the amount of changes we have now. And 8 is the maximum. So if I go, for example, higher up, it will show me, oh, you changed 12 lines out of 8. And that's not good. So now we're reaching the auto-revert limit, and I expect all the code to go away. So yeah, it's all gone. And I get notification, it's all auto-reverted. So that's roughly the setup. There is like one more thing that if I change too many lines, just to have some lines, and then I go and try and commit them, I kind of cannot commit. It says, no, it's too much. So that's now the constraint. And also, like now we have countdown of auto-revert. I can commit, then it will be reset, or I can just undo all my changes, and then auto-revert stopped again. So that's how it all works. Also, if you're not familiar with the Kotlin, this is an annotation. It's like normal Java annotation, and that's name of the function. So we define a class with tests, and then we define a function. And function has spaces because the name is backticked. And the backtick means that like you can use spaces in this name. So that's just nice for tests. And what I was also showing, 1 should equal 2, this should equal. So you understand what's going on. The full syntax is like this. So it's a function on an integer, which takes 2 as an argument. But because it's an infix function, which is like a special keyword in its definition, we can use this notation of like dropping the parents and so on. So there is nothing special about should equal, it's just normal function. So I'll reset the timer again. And so the timer is reset, and now we can write fizzbuzz with using TD. So the simplest thing we can do is 1 should equal 1 as a string. And I'll create this function. So it takes n, returns a string, and we can make it public, then import should equal. So let's run that and see how this fails. So I expected this to fail because to do is really a function which throws an exception. So it should fail now. So we can see that this line is red and it says iteration not implement. So doing TDD thing, like the simplest thing, I can just return 1 and make it pass. So right, so that's one way. And because it's working, I'm just going to commit it straight away. And once I'm committed it, so we can see the timer stopped and so on. And the next obvious thing would be to do 2. So I'll just write 2. that should also fail because we hard-coded 1, like doing TDD as you mean it. So that's expected 1, but was 2. So the obvious, simplest thing to do is just to return a string. So that should work. And the next thing, of course, is to do fees. So this passed, that's good. We can do 3 as fees. And the simplest thing, again, to do, it should be a remainder of division by 3, but for now, we'll just do hard-coded fees. And to be clear, right now, I'm like trying to push the boundary of the whole auto-revert and so on. I'll try to do it differently later on. So now then we have 4 and we can have 5, but I think I don't have time. So I'll just have to comment this out and quickly commit. Yeah, let's say it was fees. And I have like a few seconds to commit. That's a bit of pressure. So you can see I'm looking at this thing at the bottom with auto-revert and see how much time is left. So, okay, we had 5, so 5 should fail with fees. Oh, actually, that was bars. That, yeah. I should run it again, but yeah, basically the idea is to do this.
I have a question. This way of working does not permit you, or maybe the better is, doesn't force me too much fast and do mistakes.
Does it force you to do what? Sorry?
Be too much fast. So you have to be in a hurry or not?
Yeah, that's what I'm trying to do right now. But yes, it can be. I'll save this as a buzz as well. Yeah, potentially. Do you mind if I come back to this a bit later? But yeah, you're right. It's like that's what I'm having right now. So let's go from 5, then 7, 8, 9, 10, maybe 15. So then this is going to be fees, I think. This should be 7. So it's like 7, bulk editing, 8, 9, 10, 15. So that's going to be 7, 8, fees again. This is going to be bars. And well, like let's even skip this. So now all we want is like if I run this, it will fail on 6 because we're not doing remainder, right? That's what I think is going to happen. So yeah, that's this. So we need to the remainder of 3. That should pass. And then we cannot really do this again. So I'll comment this out because I cannot commit this code. It's broken. And now like I really don't have time. So I'm just like rushing it in and I can't even write the commit. I mean, just too much pressure. And so that's kind of the point that like what you were saying, if you are trying to push really hard and write lots of code, then yes, it will like be in your way and it will stress you and so on. So well, I'm running the failing test for bars. And there is also a combination, of course, which is fees bars. I'm already doing too much. So let's see this passing. And then I'll add fees bars, which is kind of a combination of the two. I think also compilation is a bit slower with Zoom than it normally is. So yeah, that all worked. And then if I do 15, this should be fees bars. And for like that's combination of 2. And I didn't even run fees bars. So I'll commit this now bars. And yeah, have to do it quickly or it's all reverted. So that's one way to attempt all of this. And it's partially because I was trying to do too many things. So now I'll try and do it in smaller steps. So for example, if we do just woof and well, I'll run woof and then I can add just woof and straight away commit it. So it's failing. I'm going like do divisible by 7 woof. That should pass and I should be able to just commit it. So iterate, so this becomes woof. I can commit that. And I still had like 40 seconds left because things are slow, but then we can have also 14 as a woof and that should just pass. And because also the changes are so small, there is a whole question of like, what do you even write in commit messages? So can I even bother opening dialog? So as a part of this plugin, there is this action called commit without dialog. So I can just press it. It just saved it now for me. It's also shortcut Command S. So it's pretty much like as a save file shortcut and it uses commit message from the previous commit. So that was woof for this, and then we will have combination of fees with, which is 3 multiplied by 7. So let's run that. And then all we need to add one more condition, I think. So that line fails. I'm adding another one, 3 with. So if that passes, I can just save it again using checkout. So pass, and I'm pressing Command Save, and it just commits without dialog. So that's like another way to reduce the pressure. And there is the whole question of what the commit, like if changes are so fine-grained, what's the point of commit messages really? So this fails as well. So we can do 5, 7, which is going to be buzz with. So that should work. And there will be a final one, fees buzz with. I'm also quite aware that this code and test, they kind of duplicate in each other. And we'll do it a bit later. So that's the final. It's fees buzz with 3 multiplied by 5 by 7. Fees buzz with. And I'll duplicate this condition and change it to 5. Oh, I didn't run the test. Let's do that. Just to follow the TDD approach. Although, like, I'm only in TDD, there should be like 3 steps. And maybe people notice that what I'm doing is just 2 steps. I make the failing test, then make it pass, and I keep refactoring, which is not entirely correct. And we'll get to refactoring step now, as it will be a kind of big bang refactoring in some way, which is not necessarily ideal. It's also, there is lots of duplication, but maybe we should have something like that over here, like +1, just to add a number which is not a combination of those, or just pick a prime number. So this is failing, it was 106. So that's like additional assertion to make sure this works. And I don't claim this as a very good coverage necessarily and so on. It's just more kind of for the demo of the workflow. And I'm saving this as well, even though this is not with now. So moving on to refactoring, which I missed out, one thing we can do is to add else, because each line has an early return. So we can just do else everywhere. Then, so this should pass. Yeah, then we can lift return out of if else expression, because in Kotlin, if else is an expression itself, it's not a statement, so we can just lift out return. You can see there were multiple returns on each line, and now like there is one return over there. So that's like another transformation in Kotlin you can do. And so the test pass, so I can just save this again. And if can be converted to this when, which is like a switch statement. So on the left-hand side, you can see the condition. And on the right-hand side, we have the string that we return. And now we also hit this change size limit. So if I go to commit and say refactoring, I cannot commit. But even in this dialog, you can actually like say, click here to force commit anyway. And this is basically a reminder for myself that just to mention the thing that this plugin or these workflows, they're not really trying to force you to do anything. It's there to kind of help you to stick to the experiment you're doing yourself. Like it's to help you, because of course it's like your computer, you can just go to terminal and do whatever you want there. So like there is no point forcing anything. And this constraint of 8 is just artificial thing I added for the demo. And so yeah, that's like small refactoring to make things a bit nicer. Another technique, so like previously when I was trying to force myself to make changes quickly, I was kind of commenting out code so I can commit it. There is another technique which helps with this tight constraints, which is to write functions and not use them. So we can define a function called fees, which is going to be like a future refactoring. And we can say if n divisible by 3, then it's a fees string. Otherwise, it's an empty string. And that's a safe thing to commit. I don't even need to run necessarily tests because, well, this is not used anywhere. And I can commit if it's like halfway, I can still commit this stuff. And I'm just writing these functions, but not using them. So it's a safe thing to commit. That's another approach, like writing code, which is not even used anywhere. So now once we have these functions, well, I'll just save this anyway. And to see that it still all works, just to prove it, then we can start using them. So the first thing we're doing is fees. Like we're continuing with the refactoring. We can plug in fees. So fees, it's a function which returns fees on empty line. So we can remove fees from the output and kind of run the test. That's one transformation. So this should pass the test. So I can save that. And obviously we can do the same with bars, say n, and just remove bars from the output. That should pass as well. And there is obviously woof at the end. So I'll save that. And like to emphasize it again, I'm finishing the whole thing like within 15 seconds, basically. So and that's always kind of the answer to like the previous question, is it too stressful? Does it make you rush? And it's like the answer is yes, but then it means that I should have done this delete woof. So hopefully this passed. So if you are in a rush, then you should find smaller steps that you can take so you are not rushed. So I'll save this too, these changes, and then we can delete all of these lines, so that will work. But we cannot delete those other 3 lines immediately. So I'll save that. If I delete, for example, this one, there will be a failing test. Let's wait for it to fail. There will be a failing test says the expected fees, but it was fees 3. And this is because this function evaluates to fees. These 2 functions become empty strings, and then in when we don't match any conditions, so we go to enter string. So basically the idea is that as soon as we get an empty thing out of these 3 functions, so we can kind of wrap them into expression, and then say if empty, then we return enter string. And if empty, it's a function that takes a lambda, and then we say enter string here, and this should go away to an empty string. So this should work as well. And then the whole when becomes redundant. So if this passes, then can just delete when, basically format this a bit. Can also convert this to an expression function, which is like a slightly more terse syntax in Kotlin. So because we only have one expression as a function, we can say convert to expression, can even drop the return type, and it's the same thing, it's just a shorter syntax in Kotlin. And I'll save this, and for like this part of the demo, that's like the final code. So yeah, that was the demo. If somebody wants to like comment on the code, because I'll just switch to slides now. Okay, I assume it all made sense. That was the demo. As a mini retro, what happened? Well, like feel free to mention if you notice something else that happened. So what I like from my point of view, had the stress from the timer in the beginning. It's like a real thing. Then it rushes me to commit or writes rubbish commit messages. All of this, yeah, it's actual pressure. And I like obviously this is a tiny demo. I tried it like on bigger like code bases, and yeah, it is a problem, but it basically teaches you to. Once you figure out how to make very small changes and you do regular commits, you just stop noticing it. Like the second part when I was doing it, I was not worried about timer anymore. So it was all good. So that's my mini retro of what just happened. Yeah, and obviously fuse bars, but I hope it wasn't like too overwhelming. Yeah. So to be fair, also the auto revert functionality, the whole idea, I heard about it from code retreats. If you never heard about code retreats, the easiest way to be introduced, just there is a global day of code retreat. If you search for it, there is a website, and it's once a year, people all over the world, they get together for a day to just practice coding. And they you usually do pair programming with test-driven development, and you split into pairs, and you have like 4 sessions a day or so, and each session has different constraints. For example, like one of the constraints you think of like pair programming, but you're not allowed to talk with the person you're pairing with, so it's a silent pair programming. That's one constraint, and they like there is no like predefined set of constraint. Really, facilitator can choose whatever they want. And one of the constraints I've seen maybe 2012, 11, I don't remember. It was the auto revert. Well, it was called baby steps. And I think, as far as I know, Eddie Bolbach came up with this concept. So it's like was his kind of idea. He used it at code retreats, and then I embedded it into the plugin. So the constraint is called taking baby steps. So I think that's where it's coming from. So yeah, so try code retreats. You can also try like other constraints from code retreats if you want to. They may be less kind of stressful than this. But yeah, anyway, so I also think it's an interesting opportunity, all these constraints, to think about them in an abstract way. So, for example, if you hear auto-revert timeout is months or years, it's like, just what I'm trying to do is just to explore all possibilities in a very abstract way. So if your auto-revert is like 10 years, you will never care probably, right? Because that's you already work with this constraint, because in 10 years you probably will lose your source code, or like you change your computer. So you already have like this constraint. So whenever people say like, oh, it's a bit stressful, it's like, well, yeah, but it's like you're already working with this technique. It's just a very long timeout. So, if we go a bit like down to days or weeks, that's like more reasonable. But again, like most people, they work with these constraints. Like if you don't commit something at work for, I don't know, 10 weeks, maybe you don't need this code really. So, maybe you should like save it somewhere else, or just don't do it. And then it becomes a bit more interesting if you go to minutes and hours. This is like what you can try on actual code bases, or this is what people do at code retreats. I did it with 5-10 minutes timeouts. That's where you start learning about like figuring out yourself how to do small refactoring steps, or do actual refactoring and so on. Well, actual refactoring is like, don't be distracted by some other things, just focus on what you're doing and finish. And if we go even further to, let's say, like auto-reverted every second, right? Then it becomes like, well, it's impossible to type anything, right? Because it's just immediately reverted. And then it kind of pushes you to maybe like pushes me to think about, well, maybe then you shouldn't type. Maybe all you should do is like a safe coded transformations, which modify your program in a safe way and saves it. And it can do in a sub-second, because it's like, it's, some computer code, which, let's say, like what you could do, define a variable with an empty value. That's a safe transformation. If like the variable name doesn't clash with anything else, that's a safe thing to do. That's like one thing. Write while false loop. That's a safe thing, right? Then, yeah, these kind of things. So like just ideas to explore, really. Then you could do similar things with change size limit. Once again, if it's like 1 million lines, like who cares, right? Then if you go to 10,000 lines, like, yeah, maybe sometimes you do it if you like, for example, rename a package, but then also it brings up the whole topic of like, how do you even count the change size? Because like, is renaming a file, is it like, did you change the whole file, right? Or if you imagine visually a diff, if you deleted a file, so 100 size, 100 lines, and this file wasn't used anyway, is that a 100-line difference, or you just deleted one item? That's like a bit fuzzy area. How do you even count that? Right. And also, like, there is a whole topic of maybe we should already get some semantic version control, which, like, if I rename a variable, it's like 1, it's not 100 files. So yeah, that's another question, how I measure this. And then like 100 lines, again, it's something you can like play with. And that's like what I used on actual projects for myself. And similarly, if you get to 1 line, once again, it's impossible to do anything. So it's like interesting parallel with auto-revert. So maybe that's like some kind of analogy, and you need to use like transformations in ID, which do it somehow very quickly. Yeah. So that's just exploring the whole range of constraints. And the other thing, which maybe wasn't that obvious, is that, and I realized it only recently, maybe in the last year or so, is that test-driven development is really work in progress limiting technique, because if you actually follow it rigorously, you're limited to initially writing one failing test. And if you're doing it like it's meant to, like the idea, the original idea, like writing the minimal test, right? So you cannot write anything very complex. Then you're not allowed to make any changes in the test. You have to pass it in production code. And then as soon as you pass it, you can refactor. So it's like you're also very kind of constrained. And ideally also when you done the circle, you can just commit. So it kind of plays well with all the other techniques. And the original auto-revert technique was actually there to kind of teach you to do TDD better. So they all kind of work together. And another thing I wanted to mention is that these might seem like a weird constraints. Like, why would you do that to yourself? That's just like, just disable this plugin. And the argument here is like, yes, but maybe it's not just a weird constraint to make you feel pain. It's a constraint that can enable you. I think like one interesting analogy is that these days, nobody even thinks about that we're all doing structured programming. But at some point, it was a massive debate whether structured programming should be a thing. And people just want like, yeah, it's also, I guess, hard to know these days whether like what was the actual difference, because I think probably most of people don't even have experience of programming in an unstructured way. But structured programming is a constraint on programming compared to assembly. And it's a constraint which I think there is a consensus that it enables people to write better programs. In a similar way, all these like weird constraints, they also help people to write better programs because we're kind of prone to making lots of changes, like very big change. Or I'm doing a feature and then I'll go refactor this too, and then another thing and another thing. And it's like, what was I doing? Oh, that feature. And now I have like 100 lines of changes everywhere. So with this kind of constraints, they push you in the right direction. So that's the idea, that these constraints not to annoy you, but like enable better behavior. That's the idea. So that was part 1. Moving on to part 2. Oh, like I'm happy if anyone wants to like chat about these things. I'm happy to.
Yeah, it's interesting. I've not actually done this explicitly, but I have sort of done that when I've been writing stuff at home. So it's my own Git commit, and I don't mind having hundreds of Git commit messages that are the same thing. Yeah. And I have sort of done that just to get quick feedback. Is basically every time I save, I also commit.
Yeah.
And yeah, never thought of enforcing it though.
Yeah.
I also use this Git alias that I call Git save, which does just put in like an anonymous no verify commit basically.
Oh, nice.
But I find that I often come back to a project and there'll maybe be 3 or 4 of those types of commits, and then it does become quite cumbersome to actually squash them together into a coherent history. I guess it depends whether you're going for a coherent history or not. Like some people think it's not even worth spending the time on like curating your history, but.
Yeah, I mean, one of the things, if you do like your plugin does, and it just repeats the previous commit, and that tends to be what I do, is just up arrow enter. So you end up with the same commit. It does sort of end up grouping them by the fact they all have the same commit message. And then if you make a slightly bigger change like you were doing, you will then change that commit. So it does sort of get grouped together by commit. And then you can do a git diff on the 2 commits or whatever to. So, but it's interesting.
I feel better now that I'm not the only weird person. So, not weird, but I feel better now.
I've never enforced it, and I've never done it at work either. That's something just at home where it's my Git commit history, so I don't care what it looks like.
Yeah, to be honest, you could just squash them like you described. If you have multiple commits with the same message, you can later on squash, rename them, and then push maybe. So you could even do it on real things, I suppose.
My technique ended up being I tend to avoid using those kind of anonymous commits now unless I just want to like get out of this branch and go and do something else in another branch. That's the most time when I use these like save point commits. And I prefer to, if I have a commit which I know I'm going to want to squash later, I'll like annotate it with at least something like an F just to tell me to use the fix up rebase or whatever.
Cool. Yeah, I think I'll move on then to TCR. Then we can have more chats at the end. Like a whole section for chatting. So part 2 will be, as promised, test and commit or revert, which is a thing which I'll explain by doing. So going back to the project. So if I go back to settings, I'll disable watchdog and auto revert, and I'll enable TCR mode. So now we have all these changes, so we don't need it. We'll do this again. It will be slightly different second time, so it's not too boring. So I deleted all the code, and now I'm going and saying like commit. Sorry, I need to select files. Why? Yeah, commit. And it says, oh, you cannot commit because it didn't run any tests. And that's the first rule of TCR, that you're not allowed to commit without running tests. So if I run tests now, well, they should pass. There is one empty test that counts as passing. So you can see test passed, and you can see all my files were just committed straight away. So you cannot commit, you have to run tests. If you run tests and they pass, it's all committed. That's the second rule. If your tests pass it, they're all committed. And third rule is that if like 1 should equal 2, if your tests don't pass, all your changes are reverted. So it's all gone now because my assertion was wrong. So you cannot do TDD with this, as you can guess. So these are the only constraints. It's also interesting, you could actually combine it with the other two, but just to simplify things, like I'll leave it as it is. So let's get on with fizbuzwoof. So it will be fizbuzz of 1 should equal 1. The other way around. It's from number to a string. So it's once again, it's the same function takes an int, returns a string. Fizbuzwoof, then I can import should equal. And the interesting thing here now, I should not run the test, because if I run it now, it will revert. So I need to implement it correctly, run the code, and then it will commit now. So I'm doing like the same change right now. So it passed and it's all committed. You see the changes on the left are gone. So it's done. Then say 2 equals 2. I should not run the test. I should just go and correctly implement the thing. And if I run it again, then it will pass. This becomes interesting because now, like, how do you even know that your assertion is actually asserting on what you just done? So for example, for fees, so then there are like different techniques to try and squeeze TDD into this. One is to say, well, we write assertion, which is like negating what we want to do. Like 3 should not equal fees. Like, yeah, it will be 3. I know. So then this should pass and it's like saves my code. So now, okay, it should equal 3 and I'll implement it as n equals 3 return fees. And I run this should pass now. So that's another way. So now let's move on maybe 2 more numbers. So we have 4, I'll do it in 5, 6, 7, 8, 9, 10. Yeah, let's do to 10 or maybe 15 will be more fun. There is no timer now, so like I don't need to worry about that. It's like 5, 6, 7, 8, 9, 10. Could have been a loop probably, but well. So 4 is 4, 5 is bars. This is fees. This is fees. This is bars, and this is fees bars. That looks good. So now we need a remainder of 3. Then 5, and fees bars at the end. And yeah, I cannot run any of this test. And so that's another interesting thing. So there is no kind of explicit limit on the amount of changes right now, but there is implicit limit because if I run this and I made a typo somewhere, it's all gone. And this way, TCR kind of pushes you to small changes because maybe if I made a typo, like, wrong letter, if you see something, please tell me, because it's all going to go away if I run it. So hopefully it's correct. I'll run the test. And that's like another constraint. It's maybe not so obvious. Luckily, it was all correct. But it's not so obvious that when you make a big change and you're like, oh, can I run the test now? So that's how it kind of encourages you to take smaller steps as well. So there is another similarity with those other techniques. So now I'm going for smaller changes. I'm just doing woof and nothing else. Yeah, maybe we should also have 11. That would be cool. Kind of contradicting my own rules just now. So that's 14 should be woof, just to add more tests. But at least it's 2 lines, maybe not too much. Yeah, the other interesting thing with this is that it doesn't force you, if you're just following the rules, like you can write code first. So I'm saying this is going to be fees woof, and this is going to be buzz woof, and I can just write that. And well, I'm allowed to run the test, right? So there is no coverage. So I wrote this code, which is not covered by anything. So, well, I can do it. That's like allowed by the rules. So I'll write in test later on. So it's going to be fees woof, which is 3.7, and buzz woof, which is 5.7. So that should still pass because we have the code for that. And yeah, that passes. And there is the final thing, which is all of these together. So I'm going for a similar thing right now for this buzz woof when we just have this kind of big if and then we refactor it. So this is hopefully this is the last change. So writing test first with TCR is a bit kind of weird. People try different things. There are also suggestions to not revert your test code. Here I'm doing everything in one file just so it's easy to see on the screen for simplicity. But there are ideas to like you revert, but you only revert your production code. And this plugin also supports this. So like if you write your own script, you can also, you can just see, oh, that's a test directory. So don't revert it, this kind of things. So it's a bit weird for like test driving things, but it's really good for refactoring. So might not be obvious, but if I move this line down, then it will fail and the code goes back to normal. We don't need to investigate, but that's like an interesting observation. I cannot move these lines up because if I move, it breaks the code basically. And as soon as I run the test, we go back to a safe thing. But like if I move around these 3 lines, they can be moved around and this should pass and then the code is saved. Just wait for that. Yeah, so in terms of refactoring, it's a bit like an arcade game. If you like reach the save point, you're there, and when it's like if you fall into lava or something, then you go back to the last place. I'll do the same refactoring again, so like add in else everywhere, lift return, and replace this with when. So these are ID transformations, so they should be safe. That's why I'm doing them quickly. And this time I'll do slightly different refactoring. So I'll extract these functions. So this is going to be fees. These functions, they only include the condition, not the string itself. So there will be like fees, which is doing 3. Yeah. Then this is going to be buzz. We'll replace all of them. And this is going to be with, once again, this is ID transformation. That's why I'm doing them quickly, because I assume that ID can do these things well. Although to be fair, Kotlin is not as good as Java still. It's quite far from it. But yeah, hopefully this was a safe thing to do. So this should just pass the test. And I'm also using like as a save button, but it's a save button which makes sure you save on green tests. So like there is once again, there is an analogy with this shortcut, which I had. It's just a different thing. And then what we want is fees of n. Well, we want a condition. So we want to say if fees of n, then we do fees. Otherwise, we do an empty string. Did I get parents right? Oh yeah, this one. Yeah, like that. And then we need to remove fees from everywhere. And then if this thing is empty, like we did before, we do n to string, and we don't do that. Right? If I run this, it should probably work. So it doesn't, and it just reverts. And this is I did on purpose. If we look, we can look at the stack trace, and here it's a small project, so you can kind of make sense of it. But the problem is with bigger stack traces, you won't even necessarily you won't be able to see the code because it's all gone. Plus, so there are different techniques to figure out what's going on with the problem. One's look at the stack trace, it takes you to the code which didn't work, then you play the computer in your head, you step through it, and you figure out what could go wrong. But here you don't even have the code to go through. So you cannot play the computer in your head because the code is gone. It's what was it? You have to remember what you just typed. So this becomes really difficult. And again, this thing is you can cheat. I can just it's ID, I can still undo the revert. But that's not the point. It's the idea is okay, that's maybe the point we should make super small steps. And what we want to do is let's try that. So the simplest thing I can think of, we have this parents and expression empty line. So that should work. That passed the test. Good. Then I can say if fees of n, empty line, otherwise empty line. So that's going to work because it's just an empty line, unless it's a performance bug here, but it's not. So that's a safe thing. So then we can add fees and remove fees from the output. That should also be a safe step. So it's a similar idea to auto-revert, taking really, really small steps. So then I can reformat that, maybe add one more line like this, saying it's going to be buzz, and buzz of empty and empty. So that's definitely a safe thing to do. I just reformatted and added expression which evaluates to an empty string. And the idea is that if I make a mistake now, I lose fewer changes, basically. So now we're doing buzz, hopefully that works. And then we can do woof. I'll be a bit more brave and just do it. We're doing woof. And then we can delete these lines like we did before, but we cannot delete easily these lines. And just like we can use the same trick as before, so we can surround all these three things with parents and say if empty. And again, as a tiny step, if empty, empty. If empty, return an empty string. So that's a safe transformation once again. And as a separate step, I can just swap empty string with an empty string. So this is going to be empty. This is going to be empty string. This is kind of what I mean by maybe transformations when you have auto revert every second. So maybe if we have like good enough tools for that, we could just do that. Or maybe if it was easy enough to write these tools. Well, to be fair, that was the. So let's finish refactoring. So I can do again expression. So that's just formatting now. I think that's a bit more understandable for me. So we have this expression here. If it's empty, we do enter string. Otherwise, we return concatenation of these three things. So now that passes the test. It's all committed. We can look at the history. It's going to be a bit funny because, well, the initial history was like one, fizz buzz, woof, 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 lots of refactoring. And for TCI, just like I went with ... dots. And they individually, they're quite small, so maybe we can name them or squash them and so on. But yeah, that's like talking about how the history looks like in this case. So that's the end of TCR demo. And to reiterate, 3 rules of TCR. You cannot commit without running tests. If your tests pass, commit is done automatically. Otherwise, everything is reverted. So the idea is, Kandalov popularized it in like 2018. I think it was that they came up with this idea to workshop. And I think Oddmanström and the other guy, they came up with this idea. So zooming in on this board, I think the idea was that on the right-hand side is a kind of state diagram for test-driven development. And they thought it wasn't very symmetric because, for example, when you have all your green tests and you do like cleanup before or after, which is refactoring, basically, you go back to green and you commit if you do like tiny commits. But when you have a broken test, you go into this broken state. And then you have to kind of fix it to go back. So I thought the idea was, my understanding is that why don't we stay in all green? Then all these transformations on the graph, they will be kind of more symmetric. And that's where the whole idea is coming from. So your code is never broken, basically. And as Ken Beck mentions in this blog post, it was also part of the idea limbo on the chip. And I think limbo on the chip, it was this concept of what if all developers, they kind of write code as you would do in Google Docs, like whatever you type, everyone else just sees straight away. The problem then is, how do you know that this code ever works? Because if everyone's like constantly typing, so like there are different ways to do it. And this is where I heard about this idea of doing small transformations in the code automatically, and this way you will never break it. So you actually never type code. You only do kind of syntax tree transformations, for example. Then you can guarantee that all these like 1,000 developers changing Google Docs simultaneously, they will never break it. Plus you will have these kind of tests running continuously. So they like implementing this kind of thing. This can be technically complicated and so on. So it's a simplification of this whole environment. The idea was like, oh, let's do TCR. And this way you can maybe like commit and push all the time, but whenever you make a change, you kind of know that it works. And yeah, and it will be very tight integration all the time. So it's almost like having this Google Doc, which is shared by everyone. So that's the idea, is kind of to experiment with that. And as I mentioned, this is a bit like an arcade game. So if you reach the save point, then if you die later on, you jump back to a safe place. If you think, you can think about gamification, but you have an infinite lives. And yeah. So there are some weird things about it, as I mentioned. So it's like you cannot really do TDD, like there are some workarounds to do it. Then stack traces might not be useful at all. So kind of the whole concept of stack tracing, playing the computer in your head, you're just like, okay, we tried that. The idea is like you think again, but you're thinking now, what is the smallest thing I can do? And this is interesting, if nothing else, just to practice yourself to do very like small focused refactorings. Then there is the whole question about commit messages, which is even bigger question now. Where do you take the commit message from? There are other ways, like even in this plugin, you can take commit message from your change list name or from your task and ID. So like in IntelliJ, you can give the name to your commit, like a set of changes. So you can take name from this. So if you're working on a Jira or whatever, some task, you can have this task and ID. So that's like one way. But then also they become so fine-grained. And in some ways, it's kind of even pointless writing a commit message when it will be more descriptive to look at the diff of what you changed, because it's like you changed the 2-1 lines and they're trivial. Often it's like, what's the point of writing a message, right? And then there is another question is like, is it commit or commit and push, and so on. So there is this also blog post about TCR variants. I'll send the link. It's like everything I'm showing is already like on GitHub, so there will be a link. So you can also watch Kandbeck doing it. Like there are some videos on YouTube doing TCR with Python. And if you want something more advanced than FizzBuzz, you can see me and Jordan doing regex matcher using TCR. It's also Kotlin. So yeah, that was TCR. And I'll move on to part 3 quickly, because there will be like parts where we can just talk if you want. So like one of the main things, what can you do? It's like you can try it yourself. It's not that hard. So if you want to do change size limit, like you can write a git hook or something like that. Like, just diff say if it's bigger than a number you cannot commit, that's a git hook. Easy, right? You can do auto revert with just Pomodoro timer, basically any timer on like mobile phones you have now. All the timers, you'll have to do it yourself. So that's another thing. You sometimes can end up negotiating with yourself, like, oh no, just this time I'm not going to revert my change. That's why they're like this automated tools, they're kind of helpful, because they will kind of do it for you.
It's like snooze on your phone. You just keep pressing snooze.
Yes, absolutely. Yes. Or you have to like have your, like maybe if you do pair programming, it's harder to like convince 2 people to convince themselves to cheat. So yeah. And for TCR, the whole test and commit and revert, so this kind of weird name, it's actually like, it's descriptive of a command you could run or could write. It's not as simple, but as a prototype, you can say gradle test, and then end means that if the previous command was successful, then you run git commit or whatever, all. Or, which means that gradle test failed, you do git reset hard. So that's like a prototype for a commit, test and commit or revert. So basically you can write your own scripts. You don't have to use plugins or whatever. Like, there are also examples of like shell scripts to do that if you search online. So, or you can roll your own, of course. So yeah, that's what you can do. Just try these things, like obviously on your, maybe not on your real project, but anyway. Or you can also obviously just like try the plugin if it works for you. If it doesn't, just ping me on GitHub. And that's what you can do. And as a conclusions, I put questions instead. So one question is just what we already talked before, like what is the point of commit messages? And this made me think, like all this kind of experimentation made me think in general, like what is the point of commit messages really? Because I think maybe lots of things that we have, maybe some of the rules, they're kind of from the past when people are making bigger changes and commit message was maybe on the line with release notes and so on. There is also a question like what we already talked about is commit message, like, is it for whom? Who's going to read it? Why they're going to read it, right? And all this kind of things. Yeah. Yeah, it's like in some cases people say like you should write, for example, some tricky problem that you solved in the code, some like the bug you fixed. But then like, I said, why don't you write it in like in a comment next to the code, so it's not buried in the commit message, right? Then if you also think about it, maybe it's like a feed of the project. It's like diary of the project. Maybe it's a diary for yourself. If it's like your project with yourself, then you write in for your future self. That's like writing a diary in some way, you know. For bigger projects, maybe it's like I don't know, it's like a Slack bot. It's like writing the history of the project, everything that happened. Maybe it's really useful because then you can see, maybe you can put more things into it. For example, one thing would be interesting to have like an actual history of all your project. It's like when people joined, and you could have like a file with list of team members, and whenever somebody joins, they add a line and they write commit message hello. So that's then if you go through his history, you'll see like not only code changes, maybe it should be like other changes, like people changing roles, all of this kind of things. Like, why don't you go for this? Maybe that's, yeah, well, what's the idea about that? Why not?
Could be interesting to know, actually, sometimes.
Yeah. So it's like the whole question of why we're even writing this.
Yeah, I must admit, some of the changes I've made, the commit message is just the Jira reference, and then the Jira has the details of the change I made, especially if you're doing feature branches or bug fix branches, so that, like we were saying, you wrap it, if you squashed your commits up to just one push for a small bug fix, well, yeah, you could put the details on the Jira.
Yeah.
I actually quite like the idea of using this for what Ken Beck calls limbo on the chip, where you have collaborative work on the project, and you have smallest possible unified work, being the working commit, that you can merge together in the sense of the document code as a document that's shared, right, asynchronously. Like Google Docs, right? Except that in Google Docs, everything you type becomes a single insert or a single delete. And in this case, it's a unit of code. And because of the time limits, for example, right, like a minute maybe, it's very constrained, it's very limited, which makes it easier to do the automated merging of changes. That is really potentially valuable because it might enable a distributed work for a large group of people on the single code base, right?
Yeah.
Concurrently, that's the important point. At the same time, all of them.
Yeah, it's also like following up from what you say. Like that's like somewhere here. It's just like, what's the point of the commits? Really, it's like what is the commit anymore? So I think maybe like commit used to be like a bigger, chunkier piece of work, and now like what you're saying is that. It's just like a save
amount
button.
Of work.
Yeah, it's like a save button maybe, because in the past, maybe like is an analogy that in the past, like hard drives or floppy drives, they were quite slow. So you would like type and then press save. So it's like saved on more kind of reliable medium, but that takes a couple seconds. So that's why there was save button. These days, save buttons, they're kind of useless. I think like IntelliJ did really well years ago when they just dropped the concept by default. So whatever you typed, it saves this for you. But now we have another medium, which is quite slow. That's like internet, you're pushing it into the cloud. And that's the new save button, basically. And if we take tiny steps, like you're saying, yeah, it is a save button, really. And then exactly what you said is like the next slide. So if we're doing continuous commits with this, like what about continuous updates? What I was doing was actually not a very good demo because it was just me typing everything. It would be awesome to do it with somebody else when we're like both typing and it's all kind of, pushed out straight away. That's
I'm pretty sure there are plugins for that on VS Code. I guess there might be plugins for it on IntelliJ as well, I guess.
But you mean
for
just
that kind of asynchronous work where multiple developers have open ID at the same time at different points in the globe, and if you work together with your plugin, then that might be a very interesting end result here, where we see what we work on concurrently, and then as soon as that work kind of makes sense, runs the tests, commit, right, and then carry on.
Yeah, that's I never thought about it. So I think what you're talking about is collaborative editing, right? It's like when you see two cursors or like four cursors.
Exactly, yes. You join that together with what you explained to us.
I forgot what. I forgot
those
what
two
it's
together.
called in VS Code.
Yeah, I don't remember either. But connecting those two together might create some interesting synergy.
Yeah, for IntelliJ, it's like Code with Me. It's still in beta or something. It's not fully ready, but yeah, it exists for IntelliJ too. I think the interesting question would be, how do you, like, people have to negotiate when to run the tests, because like if we're changing the same thing and we're like, I'm just in the middle of typing it, like something, and you run your tests and just like they're all reverted. It's like, what? Maybe it should be like a nuclear launch, like 3 people or whatever. All people say run, and then it runs.
You maybe don't revert. You just make some visual, note on the screen that those lines are not ready to commit yet. Something like that, maybe.
Yeah. There is also another interesting thing of which I didn't mention, but there was another thing about running your tests all the time. Every time you kind of finished, every time your code compiles, let's say, tests automatically run for you, so you don't even like press anything. That was another thing that people played with. So maybe that's another thing. Like, you collaboratively editing code, and as soon as the code reaches compilable state and passed all the tests, it's just saved
automatically. Yes. Just like with everything else you do on the cloud.
Yeah,
or at least the principle.
Yeah, I've got so much muscle memory. I've got Google Docs open now and making notes in, and I still press Control S every time I've made a change, and it's like, I need to do that. It's doing it for me, but it's just that inbuilt that once I've got to a safe place, I save.
Yeah.
I don't know which editor does that. One of those online things that you press Control S, it's already saved. So it does, instead, it just brings up the HTML source somewhere on the screen, which is silly.
Yeah. So I guess in some way, I'm not saying it has to be like CI, but in some way, conceptually, this is what we're talking about, just doing continuous push and update on a single branch, whatever the single representation of the project, no branches. And I think that's the actual ultimate CI. And it's really interesting that at least there is sentiment that the whole industry went in the wrong direction with all the branching, which is like Git workflow. It's basically a waste of everyone's effort. Instead of maybe making this kind of, what we were talking about, this kind of workflow possible, people focus on how to do branches better. There is also the idea that maybe some startups, it's kind of hard to write a CI server if all CI is doing is kind of just running one branch. It's maybe better product offer, and it's like easier to write for multiple branches, because there will be bottleneck of
I wouldn't go this far. I mean, in this way of working gives you a flood of commits in the very short time, right? Your single editing session could result in 1,000 of commits. So that, in my opinion, should go in a branch. Otherwise, it just makes no sense for someone who then looks at the history, in the future. And the branch would be editing session. Like this day's editing session was follows sit together here, and that is your branch. So when you run your CI, that runs on the branch, end of the session, somewhere in the middle of the session, whenever, right? But then you merge the branch and you just see, oh, that was the editing session we've done on this date and whatever, right? And you can add details later on to the comments of the merge.
Yeah, it makes sense. I guess also conceptually, even when you write any code locally, it's kind of a branch before you commit. So let's say you're on master and you type, and this is all modified code. You can think about it conceptually as a branch. And when you do actual commit all your local changes, then you kind of merge your branch. So conceptually, it's like branching anyway. I think what I was remember what I was trying to say is that CIs, they're not really doing proper CI, because normally I think you would have multiple branches, they integrate with master and make sure that they work with master, but they don't integrate with each other in CI. So in reality, if you want full continuous integration, you need to integrate all branches with all branches, which is like a very high complexity problem. And that's why it's like, you kind of can do it with just like everyone having very short branches. And
exactly, yes.
And those branches, they could be just local change, like.
Yeah, or you just don't keep branch aging over 1 or 2 days. That's it.
Well, yeah. I guess ultimately, whatever works for people is just interesting that, everyone went for branching instead of trying to integrate really tightly. So then I think the other problem, to be fair, and there are good reasons this is happening, the other big reason is that for these kind of workflows or for tight integration, our tool chains are not that good, really. So, for example, just the compilers. I don't
Yeah,
think
especially some fancy C++, which I like to write, to be honest, might just slow the whole thing down a lot.
Yes, and I think also I'm a bit disappointed because like when I started programming like late 90s, then it felt like things were faster than they now in some ways, and especially frustration because computers are like way more powerful, but like the tools are like the same or slower speed. That's my impression. This is really weird because I mean I can understand that maybe some programs they can slow down for maybe I don't know other target audiences, but like as developers, we are literally writing these tools. Why can't we make them faster for ourselves? I mean, seriously, why don't we make a big fuss and just say like, look, like we want it to be lightning fast. As soon as my finger leaves the button, it should be finished compiling. So it's like, yeah, like I don't know.
Yeah, there's definitely some of that. I have had that. We had a project that compiled in 3 minutes 10 years ago. And now the same project takes over half an hour. Give or take, it's not significantly different.
Yeah. So yeah, for obvious reasons, if it takes you even 3 minutes, you cannot have auto revert every 5.
This is the whole project, so there's a lot of units and components in there. So yeah, you don't have to build all of them each time, but it still just shows that somehow we've managed to bloat it that much.
Yeah. Yeah, it's a bit unfortunate. Also, I think text editors, they are heavier and not as snappy as they used to be. Just like press and compile, it takes longer somehow with all the tooling, even before it hits the compiler, I mean. So like the whole tool chains, I think for most languages, not very good. There are some exceptions. I think Go is done well, at least for small projects, it's super fast. I don't know how it works on bigger real world projects. Maybe it ends up being slow as well. And I think another big difficulty, it's not just the compiler, it's also lots of our projects, they have really slow tests, right? Usually like they take many minutes. And if you have like workflow which undoes something, you cannot like wait for half an hour and then it's like, oh, actually it didn't work.
Yeah.
and you cannot see stack traces, like what?
Yeah.
And you can't even remember what you wrote.
Yes.
I think it's one of those problems that actually this could be fixed with a little bit of education and unfortunately improved design, which sometimes is very difficult. The point being that people sometimes don't distinguish between unit tests and acceptance tests.
Yeah.
Unfortunately, which are, different things really.
Yeah, well, yeah, I think that's like answering my previous rant, why it's hard to do CI for this continuous integration very tight, because lots of things, they don't even depend on you. It depends on compiler, on like the actual tests you have in the project. So that's why it didn't happen. So there are reasons. So I'm just doing this as an aspirational thing. Why don't we do it? And like, actually, it's not that simple. And the other question I had is like, what everything I showed was applied from developer point of view, but should we do it actual end to end? Because like in the example I was giving in the beginning, so it's developing a website, maybe we should like write some code, like make sure the test pass, then we just do push, and then we go and look at the website and see if it's there the way we want it to be, right? So it should be actual end to end, not just dev done and then throw it over the fence and expect somebody else to kind of actually monitor it. Yeah. So yeah, and on this topic, it's also like sometimes feedback is quite fast, but sometimes it like takes on the bigger like maybe it takes some time for users to actually find this feature or click on this button. So maybe there should be more feedback loops in IDE or editors. So when there is some kind of exception, or even just like code metrics, like why don't we run our profilers all the time in production? Right, then you have your performance statistics. You can see how much each line is executed on the real project in the last week. If you have any exceptions, or if you have a try catch, but there are no exceptions, the other case, why don't we get all this data in IDE or editors just out of the box? Or why nobody's talking about this? That would be awesome. You're basically doing it more kind of end to end, but with some delay. So to give an example, if something breaks in production, like you made a change, we pushed it, we've looked at the page, looks okay, and then an hour later some user comes in and something doesn't work for them, there is an exception, we should just see it in ID, because, well, like there should be a way to figure out that's the code which just changed, and it had, let's say, this commit message with authors, and we ran in our editor with like logged in or something, and it just shows us like, oh, the code you just committed, that thrown an exception, like, okay, which line, and you just go and fix that. Like, that would be one thing, instead of like going through several tools and monitoring things and so on. Right? So it's kind of, feels like
it'd be interesting. Yeah, if we're doing sort of continuous deployment, as you say, and then it monitors the logs, use Git blame to figure out who did it and push it through to the IDE.
Yeah. And I guess this way, with this more feedback, it will also kind of limit your work in progress, maybe in some way, because you could you could maybe wait for this feedback and see if you could have code coverage in production all the time. You could like deploy the change and maybe look in your IDs, like, is anyone running through our new code and how many times it went through it? So if 0 is like, it's clearly not being used. So should we go and click ourselves, like click a few times? Okay, we see in our code, it was executed 3 times. This kind of things, I think it's similar.
And then you could do the whole blue-green thing as well. And
actually, you could take this idea to production, like you deployed new code, throws an exception, revert. Just like it goes away to the previous successful state, just based on statistics.
And the more times it goes through that, the more it pushes it over so that it's 100% live.
And there are, like, again, why is it not done? Because I think there is not much focus in the whole industry, plus we whole, again, very bloated tool chain, because the whole deployment pipelines, they're even slower than unit tests, and they're like very complicated. And like as an example, there are projects which are trying to address it, like for example Darklan. I'm not like, that's with the question mark, I haven't properly tried it, but they have these ideas, if you read the blog post, of pushing to production is like milliseconds. And this way, because they're not going through pipeline, they're like using different techniques and they're kind of patching it and so on. Maybe also there is like something to learn from Erlang, because it seems like they've been doing some of these things, like quickly pushing things into production without waiting for an hour and so on. So that's another area where our like the whole deployment tools, they're just so bloated and slow, and nobody kind of thought about them end to end.
It's one of those interesting things that again, for a home project, so it doesn't really matter if it goes wrong. If you're doing like something like PHP, you save and that's it, it's in production. If you're editing live in the HTTP directory, probably not a good idea, but you can do it. And then, save is live.
I think also with this continuous things, there are things which should be kind of helped at the language level. I think Darklan is doing this. For example, like what you're saying in PHP, if it goes live straight away, it's kind of a bit dangerous. Because
definitely.
Especially in a way, like in the first place, it just goes live. But then there are things like if you want, for example, to rename a column database or like modify some endpoint, you probably should do expand and contract technique. So you like add in a new endpoint, then your code starts using it. Then you can, as a next step, when everything is deployed and working, you can delete the old one. And this is a manual thing. It manual as in, to do it right, you have to be careful, basically. It depends on humans. It's like, why don't we have it as a part of the language kind of design where you could like migrate your types? I don't know. It's like, I think they're doing something like that in Darklan. So that's an attempt to embed all these concepts together in like one environment. So that's
it occurs to me that since we are, we have all the Git history here, we're going this through Git, then GitOps might be somehow maybe be useful there, except that we want to kick out Jenkins or Travis whatever from the loop because they're just too slow. But Git has a hook, so you can do something smarter in Git hooks on the server side, right?
Well, I think what Darklan is doing different is that it does incremental compilation. Like Git hooks, I think they could, but it does incremental compilation, then like sends a patch. I think that's why it can be so lightning fast. Anyway, so everything I showed is on this GitHub repository. This is really the end of the slides. Thank you for watching.